of Management Studies IGNOU presents an audiobook on the course Mmpc 015 Research Methodology for Management Decisions for MBA program. Presenting Block 3 Data Presentation and Analysis, Unit 9 Statistical Analysis and Interpretation of Data, Nonparametric.
Objectives. On successful completion of this unit, you should be able to 1. Explain the differences between parametric and non-parametric tests. 2. Describe the relevance of non-parametric tests in data analysis. 3. Discuss the steps involved in the non-parametric test. And 4. Design and conduct one sample, two samples, and more than two samples non-parametric tests. Introduction. In Unit 11, Block 3 of Quantitative Analysis for Managerial Decisions, Mmpc 005, you have been introduced to the general class of testing of hypotheses. These tests, popularly known as parametric tests, assume that parameters such as mean, standard deviation, etc. exist and are used to develop a test. For example, a t-test is based upon the comparison of means of two samples. The parametric tests are developed with an assumption that the form of the population distribution was known and that a test concerning a parameter of the distribution was to be made. Tests of hypotheses which deal with population parameters are called parametric tests. There are situations, particularly in psychological or in market research studies, wherein the basic assumptions underlying the parametric tests are not valid or one does not have the knowledge of the distribution of the population parameter being tested. The tests which handle problems of these types are known as non-parametric tests or distribution-free tests. In the recent past, the non-parametric tests have gained importance basically for three reasons. 1. These tests require no or less restricting assumptions than the corresponding parametric tests. 2. These tests are more suitable for analyzing ranked, scaled, or rated data. And 3. These tests involve very few arithmetic computations. However, it must be understood that when basic assumptions about the parametric tests are valid, the non-parametric tests are less powerful than the parametric tests. Thus, there is a greater risk of accepting a false hypothesis and thus committing a type 2 error. Secondly, in non-parametric methods, the null hypothesis is somewhat loosely defined, thereby, when the null hypothesis is rejected, the non-parametric tests yield less precise conclusions compared to the parametric tests. For example, in parametric tests, we have a test for the equality of two population means compared to the two population distributions are identical in a non-parametric test. In this case, a rejection of null hypothesis in a parametric test would mean that the two population means are not equal, while the rejection of the null hypothesis in the non-parametric test leads to the conclusion that the two population distributions are different. The specific form of the difference between the two distributions is not clearly specified. The following are some of the typical situations for using non-parametric tests. 1. In a consumer behavior survey for a new package design, the responses are not likely to be normally distributed but clustering around two extreme positions with a very few respondents giving a neutral response to the package design. 2. Sometimes the responses to a question are given in terms of names which cannot be treated as numbers. For example, if we ask young graduates, in which part of the country would you like to take up a job and live? The replies could be north, northwest, west, or south, etc. Nominal data can be analyzed only by non-parametric methods. 3. In mailed questionnaire method of survey, more often partially filled questionnaires are received. Non-parametric tests are designed to take the mission's data and make necessary adjustments to extract maximum information from the available data. 4. Non-parametric tests can be used to provide reasonably good results even for very small samples. One-sample tests. The one-sample tests are used to answer the questions such as 1. Is there a significant difference between the observed and expected frequencies? 2. Is it reasonable to believe that the sample has been drawn from a specified population? 3. Is it reasonable to accept that the sample is a random sample from some known population? The tests which are used to obtain answers to the above question are classified as tests for goodness of fit. Kolmogorov-Smirnov one-sample test. This test is used for comparing the distribution on an ordinal scale. The test is concerned with the degree of agreement between the distribution of observed values and some specified theoretical distribution. It determines whether the scores in a sample can be reasonably be thought to have come from a population having a theoretical distribution. Two-sample tests. The two-sample tests are used to evaluate the effectiveness of two treatments, two methods, say teaching or two promotional strategies in marketing. In each of these cases, the sample which has been administered with the treatment is compared with the one which has been administered with another treatment. For example, while comparing the two advertising strategies on two groups of consumers, one group might react differently compared to the other, not because of the advertisement alone, but also because of other factors such as their background, social status, etc. In problems of this type, there can be two independent samples or the same sample studied again, that is, before and after the advertising campaign. The median test. The sign test discussed can be used only when the observations are paired, that is, the elements are studied before and after the treatment. This may not always be possible, as we may have samples of different sizes from two populations. In such a situation, the median test is appropriate. The median test is used to give information on whether the two independent samples belong to the population with the same median. The Mann-Whitney U-test. This test is used to test whether the two samples have been drawn from the same population. This is a most powerful non-parametric test as it could be used for both qualitative and quantitative data. It is a very useful alternative to the t-test when you may wish to avoid the assumption of t-test. Wilcoxon matched pair signed rank test. You would recall that in the sign test, the value of the difference of scores was used only to determine its sign, but its magnitude was not taken into account. The Wilcoxon matched pairs signed rank test incorporates this additional information and attaches a greater weight to matched pair, which shows a larger difference. This is therefore a more powerful test than the sign test. K-sample tests. The tests discussed earlier are concerned with one or two samples. There are several situations where we will have to handle more than two samples simultaneously and decide whether or not these samples belong to the same population. For example, in a large unit, a product is produced by several machines simultaneously and samples are drawn from each machine's output to test for quality. The production manager would like to test whether all the machines produce items of the same quality. The Kruskal-Wallis test. In this test, all the elements of different samples are pooled together and they are ranked with the lowest score receiving a rank of value 1. Ties are treated in the usual fashion for ranking data. If all the samples belong to the same population, then the sum of the ranks of the elements of each sample would be equal. Let Ri be the sum of the ranks of the elements of the ith sample. The Kruskal-Wallis test uses the X-square negative test to test the null hypothesis. Summary. In this unit, we have introduced the role of non-parametric statistical tests in the analysis of statistical data. When the basic assumptions underlying the parametric tests are not valid, or when one does not have the knowledge of the distribution of the parameter, then the non-parametric tests are the appropriate tests to draw inferences about the hypothesis. These tests are more suitable for analyzing ranked, scaled, or rated data. However, when the basic assumptions underlying the parametric tests are valid, the non-parametric tests are less powerful than the parametric tests. Therefore, if for such problems non-parametric tests are used, there is a greater risk of accepting a false hypothesis and thus committing a type 2 error. These non-parametric tests are grouped into one sample, two sample, and k-sample tests. One sample tests are used to study whether there is significant difference between observed and expected frequencies, or whether it is reasonable to accept that the sample drawn is a random sample, or whether the sample has been drawn from a specified population. The two sample tests are used to study the effectiveness of two treatments, two methods, or two strategies, etc. In problems of this type, there can be two independent samples or the same sample elements are studied again. K-sample tests are an extension of two sample tests. Here, instead of two samples, we have more than two samples being studied simultaneously.
You were listening to the audiobook by the School of Management Studies IGNOU for MBA program. Course code Mmpc 015 Research Methodology for Management Decisions. Course Coordinator Dr. Venkataya Chittipaka, Associate Professor from School of Management Studies IGNOU. Voiceover by Renuka. Edited by Savita. Program assisted by Tarannum Jahan and Jagbandhu Jana. Program produced by Dr. Manoj Kumar Singh. This program was brought to you by Electronic Media Production Center of Indira Gandhi National Open University.